Here's a problem that we talked about in one of my 130 sections today. I'm going to give you this example, work it through, and give you another example, which I covered in both classes, but wanted to present in a more coherent fashion. I'm going to start working through this problem by looking at the angles. And in both cases, I'm looking for the sine of the angle 3x and the cosine of the angle 3x. Therefore, I'm going to let 3x equal alpha and rewrite what I have there. Now that I have it in that form, I'm going to refer to my reference sheet. On my reference sheet, I don't see 4 times the sine of alpha cosine alpha, but I do see this. I can find this 2 sine alpha cosine alpha within here if I simply rewrite that 4. And now I can see 2 times the sine of alpha cosine alpha, just like I have it here. Therefore, this entire expression is equal to the sine of 2 times alpha. Resubstituting 3x for the alpha, I get this, and the most simple form of the original expression would be this, 2 times the sine of 6x. I will use the same substitution and the same double angle formula to work this next example. Notice in this case, though, I'm looking at 4 in a different manner. I'm looking at 4 now as 2 squared. I now have the sine squared of alpha when I substitute alpha for my angle 3x, and I'm multiplying that by the cosine squared of alpha. Now let's rewrite the sine squared alpha the way your calculator likes it. Because when we do that, we begin to see some exponents in their usual positions, and it becomes more apparent that we can apply the law of exponents. This step is not technically necessary, it just makes it easier to see that these squared, or exponents to the power of 2, can be pulled out side parentheses, and this expression is equivalent to this expression. Now that we have 2 times the sine of alpha times the cosine of alpha, that's exactly what we have over here. So everything within that parenthesis, the pair of parentheses, is equivalent to the sine of 2 alpha. Note that we are not just bringing this 2 inside. We are saying this entire expression that we have here is equivalent to the sine of 2 alpha. The derivations are in your e-text if you want to see why this is true. We now resubstitute 3x for alpha, giving us the sine of 6x squared, or as it is most commonly and properly written, the sine squared of 6x. So there you have 2 quick examples, a little challenging there, but you are working from the more complicated side of the double angle formula to the less complicated side. We are simplifying.